Hello, welcome to our cubic function. Okay, so of course we're going to start with the parent function. Parent function has parent function points just like all of the other functions did. So for our cubic, the x values go from -2 to 2. And the reason being is because if I, well, just like the parabola, you can substitute those values in and get a corresponding y value. There are no restrictions on the cubic function. So -2 cubed is -8, and that corresponds to -1, 0, 1, and 8. So ladies and gentlemen, when we use our transformation tables, and that's what we're going to really be stressing, some of you are resistant. Fair enough, but now is the time to stop, because when we get to various higher order functions and when you're doing with square root, cube root, trig functions, when we graph those, you can't just plug and chug anymore. Okay, you've got to use 1, 2, 3, 4, 5, 6, 7, 8. There we go. You have to use those transformation tables. Okay, so there's my PSA for the day. Here is what our parent function for the cubic looks like. It's so pretty. Okay, so for our parent function, hk is 0, 0. The x and y intercepts are 0, 0 because there are no transformations yet. It's the parent function. The domain is all real numbers or -infinity to positive. Remember, we need to get comfortable with that interval notation. The range is also. For these functions, for our cubic functions, they're either going to increase or decrease. With the parabola, we saw both. For these, you're just going to do one or the other. This one, remember, it's where your pen or pencil goes from left to right. This one increases, so the interval is from -infinity to positive infinity. Okay, those are your domain elements. It is 1 to 1. Okay, it passes the horizontal and the vertical line test. Rate of change varies because it's growing exponentially, so we're not going to find that. These functions do not have an axis of symmetry because it is not symmetrical. There is no minimum nor maximum value because they shoot off to positive and negative infinity. And then there aren't any asymptotes. So the characteristic chart is definitely very plain and simple, we'll say, for cubic functions. All right, so there's the parent function. Yay! Let's move on. Here we go. Remember, you could also have a b value. Now, several of you are forgetting to factor out that b value before you find your hk. Ladies and gentlemen, that is crucial. Okay, that is the general form. Here we can see that for this example, a is -1. There isn't a b value other than 1. H is -6 and K is -4. For H, you're always going to take that opposite sign still because in the form, in the equation, it's X minus H. Okay, that's why. Now, for our transformation chart, it's always written as the reciprocal of B plus or minus H, and then AY plus or minus K. Okay, we've talked about this before. Some of you are using it. Some of you, we need to use it a little bit more. Okay, so there it is. If our b is 1, there isn't a horizontal stretch or compression, so we're just going to say x minus 6 for this example, and then -y minus 4. Okay, 1 over bx plus or minus h, ay plus or minus k. And as I've done in the past, I'm always going to write out the parent function points next to my transformation table, just so that I can refer back and forth to what I'm plugging in. All right, for the x values, we're going to take -2 and substitute it in for x. So that gives us -8. If I plug in -1, I get -7. 0 gives us -6. 1 gives us -5. And 2 gives us -4. Okay, we're just taking our parent function points and substituting them into the transformation table. If I take -8 and substitute that in for y, because that's my first y value, I get 8. 8 minus 4 is 4. Substitute in -1, we get 1 minus 4 is -3. If we substitute in 0, we get -4. If we substitute in 1, are you having fun yet? Yeah. We get -5, and then if we substitute in 8, we get -12. All right, go ahead and graph these with me, please. So we have -8, 4, and then -7, -3. -6, -4, and so forth. For the 12, yeah, you're going to have to guesstimate a little bit, but that's okay. Do the best that you can. And our cubic is a little bit curvy, so that's what it looks like. For the transformations, there is a vertical reflection because of our a value being multiplied by a -1. Like I mentioned earlier, there isn't a horizontal stretch or compression because B is 1. H is -6, so we're going to do 6 units to the left. And K is -4, so that means we're going 4 units down. Transformation language, you guys, it doesn't change. I've said that and I will continue to say that. It doesn't change just because we're graphing a different function. It still has the same effect. Okay, our HK is not a vertex. No, it is just HK. Our starting point, our central location is -6, -4. There is an x-intercept, and we need to solve for it. All right, let's do it. I dare ya. So for the x-intercept, we plug 0 in for y and set it equal to our function. All right, let's go. So I'm going to add 4 to both sides. So 4 is equal to a negative x plus 6 quantity cubed. Divide by -1, so we get -4 is equal to x plus 6 quantity cubed. I have to take the cube. Oh no, can I take the cube root of a negative value? Yes, you can. So I'm going to take, oh, I don't know why that thing's there, sorry. I'm going to take the cube root of -4. It is not a square root, ladies and gentlemen. It is an odd index. It is an odd radical. So yes, you can absolutely take the cube root of that. Last thing, actually, we don't need those parentheses anymore. Let me take them away. Last thing is to subtract the 6 to both sides. And that means that x is -6 plus the cube root of -4. We don't need plus and minus because, again, this isn't going to be a square root. Sweet, nice job. Okay, there is a y-intercept, but we don't know what it is, so we're going to have to solve. Whoop, whoop. All right, y is equal to negative. We're going to plug 0 in for x this time because that's what we do when we're finding the y-intercept. We get -6 cubed minus 4. 6 cubed is, well, 6 times 6 is 36. If we cube it, why did that pop up? Ay, ay, ay. Okay, obviously I am learning. Do you want to stop? No, I don't know what's going on. Okay, I'm learning how to do this. Sorry. So we get -216 minus 4. So that's -220. Sorry for that little intermission. If I can edit it out, I will, but realistically, that's not going to happen. Okay, so it is 0, -220. Ladies and gentlemen, you're welcome for not having to graph that. Our domain is all real numbers. Because this is the cubic function, there aren't any restrictions on the domain, nor are there any restrictions on the range. It is free-flowing in both directions. Now, because there's a vertical reflection, we're going to say that this, oh gosh, whoa, nope. This is decreasing the whole way. So it decreases from -infinity to +infinity. It is 1 to 1. The rate of change varies. There isn't an axis of symmetry because it's not symmetrical. There are no minimum or maximum values because the function goes on forever in both directions, and we don't have any asymptotes. Yay! Okay, so there is our first example beyond the parent function. Last example we need to look at is with a b value. What do we have to do with a b value? Factor it out. Yes. Do not forget that. Many of you are forgetting that. Stop it. So then if we factor it out, factoring is just dividing. 4 divided by -2 gives us -2, and everything else stays the same. So our a value is 1/3, which means there is a vertical compression. The b value is -1 times 2. H is 2, and k is -1. So we have a vertical compression. Okay, we have a horizontal reflection because there's a negative in front of the b value. We always address the reciprocal of the b value, which means it's a horizontal compression. And then if h is 2, that means we are going 2 units to the right. K is -1, that means we're going 1 unit down. And that's going to help us set up our transformation table. So it's a negative 1/2 x plus 2, reciprocal of the given b value times x. And then 1/3 y minus 1. Okay, for our parent function points, we have -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. All right, let's do it. If I plug in -2, I get 1. 1 plus 2 is 3. Plug in -1, we end up with 2.5. 0 is 2. 1 is 1.5, and then 2 gives us 1. All right, if we plug in -8 to the y values, you get -8/3. Common denominators means you have -8/3 minus 3/3. So that is -11/3. Or we can say -3? Yep, and 2/3. If we plug in -1, we get -1 1/3. 0 gives us -1. 1 gives us a -2/3. 8 is going to give us 5/3, or 1 and 2/3. Now, if you have to write that out, do it. Just because I'm not writing it out doesn't mean it's bad to write it out. Okay, you need to do what is most effective for you, please. Okay, so we go 2, 3, and 1, 2, 3. I need to make this a little bit bigger. Sorry, so 3 and -3 and 2/3. Do the best that you can to approximate that location. 2.5, -1 1/3. So I'm going to go to 2.5, -1 1/3. Oh my. There we go. 2, -1. 1.5, -2/3. Oh gosh, this thing is a little touchy. There we go. Oh no, come back. 8 years later, I'll graph that point. Hopefully you've continued. There. Oh, it hates me. There we go. And then 1, 1 and 2/3. All right. So, it looks like it's a vertical reflection, but we know by transformation language that it is not. It is a horizontal reflection. For this particular function, it has the same effect visually. Okay, so HK is not a vertex. HK is 2, -1. There is an x-intercept. We need to solve for that. Okay, so we're going to plug in y as 0. So we get 0 is equal to, you are more than welcome to use the factored out version or the original. It doesn't matter. I'm going to use the original. Cubed minus 1. Okay, so I'm going to add 1 to both sides. 1 is equal to 1/3 times the quantity of -2x plus 4 cubed. Multiply both sides by 3 to get rid of that 1/3. So 3 is equal to the quantity of -2x plus 4 cubed. Take the cube root. So now we have -2x plus 4 is equal to the cube root of 3. The cube root is not a square root. It is an odd index, so we don't need that plus and minus. -2x is equal to -4 plus the cube root of 3. And then divide everything by a -2. So x is equal to 2 minus 1/2 cube root of 3. Or if that bothers you, you can write it as 2 minus the cube root of 3 over 2. Doesn't really matter. It is the same thing. So 2 minus 1/2 times the cube root of 3, 0, whoop, whoop, is our x-intercept. There is a y-intercept, so we need to solve for that as well. I'm going to go ahead and plug in 0 for x like we did on the last example. So -2 times 0 plus 4 cubed minus 1. All right, that leaves us with 1/3 times 4 cubed minus 1. Order of operations, cube first. So we have 64 minus 1. All right, so then we get 64/3 minus 1. Common denominators is going to leave us with 61/3. It doesn't really matter. Yes, write it in coordinate form, but it doesn't matter if you put it in a mixed number. Decimal matters if you're approximating. For this one, we would have to approximate, so leave it in fraction or mixed number, please. Domain is all real numbers because, again, the cubic function, you guys, doesn't have any restrictions on the domain or on the range. There aren't any values that can't exist in their x or y values. Because of that horizontal reflection, we are going to decrease. from negative infinity to positive infinity. It is 1 to 1. It will always be 1 to 1 unless there's some really funky stretches and compressions going on. The rate of change varies because it's growing exponentially, or decreasing, I should say. No axis of symmetry. It is not symmetrical. There are no minimum or maximum values because it's growing and decreasing to positive and negative infinity. That is a concept, not a value. Asymptotes you will see next unit. And so, ladies and gentlemen, that is our cubic function. Please know that the cubic function, not hard, okay? Same thing, all the transformations apply, A, B, H, K, factor out the B value. If you need to, write that down, write yourself a reminder, please do something so you remember to do it. And then our parent function points that we plug into the chart. All right, I'm gonna attempt to shut this off, wish me luck.